Back to my channel, and in this video we are going to learn about extended master's theorem. Okay, it also has the same equation as the master's theorem, that is T of n is equal to a times of T of n by b plus f of n. Now here there are some conditions for this, that is the value of a is greater than or equal to 1, b is greater than 1, and k is greater than or equal to 0. See, k would come in the f of an equation. Okay, and the condition of p would be given in the cases. Let's discuss it below. So now I'll tell you the basic difference, like when you have to use master's theorem and when you have to use extended master's theorem. So master's theorem, you can use it if you are having your function f of n in terms of n, n square, so on up to n power k, or you are having some basic logarithm of a base b. But if your function is like n log n square log n, or n log n whole square, if you are having terms like them, then you need to do extended master's theorem. So this is the basic difference. So now let's see how we use it. So there are basically three cases. When you see the first case, here we compare a and b power k. Okay, in the last one, in the master's theorem we have compared f of n and logarithm of a base b, but here we are comparing a and b power k. We also know that what is b power k, it is nothing but the power of n in term of f of n. So when a would be greater than b power k, then your time complexity for the given recursive relation would be theta. Theta is nothing but here average time complexity. Okay, big O is nothing but best case, and omega is nothing but worst case. So this lies in between is theta. It is nothing but average case. Okay, now if a is equal to b power k, then there would be three more conditions, that is p. Where we have seen p, it is the power of log. Okay, so the power of log, if it is greater than minus 1, then it would have one time complexity. If it is equal to minus 1, then it would have a different time complexity, and if it is less than 1, then it would be different. If you come to the case 3, that is a less than b power k, then again we have two more conditions to check, that is of p. If p is greater than or equal to 0 or less than 0, then this would be their respective time complexities. Okay, so now let's understand this using some examples, and in the last there's also a bonus question, and that's for you to solve, but I'll give you a small hint to solve that. Okay, the first question is 2tn by 2 plus n log n. So if you identify the function over here, it is nothing but n log n. Okay, and if you compare this with the original equation, that is t of n is equal to a tn by b plus f of n. Okay, then from here we can say that a is equal to 2 and b is equal to 2. Now what we need to get more? The value of k. So the value of k is nothing but it's the power of n in terms of f of n, that is 1. The value of p is also equal to 1. So now what we need to check? We need to check a and b power k. Okay, let's see what is a over here, 2. What is b power k? That is 2 power 1. So they both are equal. So which case is this? It is the second case. Now what we need to check next? The value of p. What is the value of p for the given question? It is 1. So where would it come? It is greater than minus 1. So the time complexity would be order of, theta of, so T of n would be simply theta of, it would be n power log a base b into logarithm of p plus 1 into n. Okay. So we just simply have to substitute the values. N power log 2 value, log a is 2 and b is 2. Logarithm of 1 plus 1, that is 2 n. So this would come out to be theta of log 2 base 2 value is 1. So it is n log square n. So this is the value of T of n. So let's go to the next question. In this question, now again if we compare it with the original equation a T of n by b plus f of n, then the value of a would come out to be 4, the value of b would come out to be 2, the value of k, before that let's write f of n, that is equal to n square. So k is equal to, it would be the power of n, so it is 2, and p here is 0 because there is no log term. Okay, if he has mentioned something like this, he will give you in the question that solve it through extended master's theorem, then you need to use this. Okay, so now we need to check the a and b power k values. So a here is 4 and the value of b is 2 and k value is 2. So they both are again equal. So this would come out to be case 2. What next do we have to check? The value of p. Okay, here the value is 0, which is again greater than minus 1. So our time complexity would be theta of n power log a base b into logarithm of p plus 1 in the power with the value n. So simply we need to substitute the values, that is n power log a value is 4 and base is 2, log 0 plus 1 is 1 and n. So log 4 base 2, how do we solve it? Log 4 can be written as 2 square and this power would come in front, so it would be log 2 log 2 base 2. Log 2 base 2 value is 1, so this is 2 into 1 equal to 1. Okay, so this value would become 2, so n square into log n. Therefore, T of n would become theta of n square log n. So this is the value. So the next question is a homework problem for you, wherein you have to be careful at this term because he has given us 2n by 3. But what is our general equation? It is n by b. Okay, T of n equal to a into T of n by b plus f of n. Okay, other all terms you can identify, but sometimes you might miss in this. See, the coefficient of n is 1, but here it is 2. So this 2 would be in the form of division for 3. So this would come out to be like this. Okay, now the value of b would be 3 by 2. You might get confused, so please look at this. Now using this, solve the following problem and your final answer would come out to be this. If you get the correct answer, then do comment your answer in the comment section below, and hope this concept is clear for you. If it's clear, then don't forget to like, share, and if you're new to my channel, then don't forget to subscribe to my channel. See you in the next video. Until then, bye bye.